This is a question that asks how we could minimize the distance that we have to walk when we're cutting the lawn. And at first I was going to skip this question just because if you actually seriously want to answer this question using mathematics, there are so many things that you would have to think about that it's pretty much impossible to answer using the level of math that we have right now. I did a quick search for optimal lawn mowing patterns, and there's one person who used all kinds of calculus, and they were talking about how long it took to turn the lawnmower around, whether you sometimes would go forward and then back up because that was faster than turning the lawnmower around, and all of these things that you would have to take into account. How much of a gap are you leaving between each row? So for example, the assumption would be here in this question that your textbook is saying that if you use the lawnmower that you can go exactly beside this row that you've just cut with your lawnmower, which is not true because the lawnmower you need to have a little bit of overlap. Anybody who's cut the grass would know that if you don't have that overlap, you're going to have these little tufts of grass that are going to be in between the rows and so on. So, pretty much an impossible question to reasonably answer. And so they're just saying, approximately how far would you have to walk? You start at A and you're supposed to return to A when you finish. If you go along the perimeter versus in rows, how would that affect it? So if you went along the perimeter and you did something like this, and you actually stop, you're going to get this kind of spiral where you're going to get something that's going to look like that. And then what will happen is, depending on where you end up, you still have to make it back to A. You can have all kinds of complicated ways of interpreting this. But because the answer I got was actually exactly what the textbook has, I knew exactly how they tackled the problem, which is in a very, very simple way. So if you're interested, and you're still listening, I will go through how I got the answer that was in the back of the book. And so, like I said, if you looked at this question, you're thinking, well, that's impossible. How am I supposed to figure that out? I figured exactly the same thing. There's so many possible variables, and people think about this stuff, who are the real brainiacs, and they do it in theory, and it helps them to develop their mathematical skills because they're coming up with all kinds of mathematical theories using spirals and calculus and things like that. Anyway, I'll go through the solution now. So one thing that I did see when I was doing my quick search is that if you're going to cut the grass, the most efficient way to do it is to go the long way back and forth instead of the short way, and that just means you have fewer turns. So if you were cutting the grass, and often it's impossible, you've got like a tree and a planter and you're having to go around those things, but if you just have this piece of grass and you're going to cut it, for sure you're going to want to go this way because you can go longer without turning. So that was the assumption that I made, and that helped me to get to the answer that was in the back of the book. So what you would want to do is figure out, well, how many times do I need to go back and forth if each row is chopping off 52 centimeters? And like I said, it's a bad assumption because we'd have to have some overlap. But if we can cut an exact width of 52 centimeters, the first thing that I would want to know is how many times do I have to go back and forth. So I'm going this way, turn around, going back, turn around, go back, and so on. So I took 13.5 and I divided that by 0.52. So the whole reason for this lesson is converting units. There are 100 centimeters in 1 meter, and notice that this is given in meters, so you'd either have to convert from meters to centimeters or centimeters to meters. So I use 0.52. 52 centimeters is 0.52 meters. In order to get from centimeters to meters, I need to divide by 100. So I took 13.5 divided by 0.52, and I got 25.9615. So we have to go back and forth, let's say 26 times. I use the exact number, which is ridiculous. And I'll use 26. I'll use my calculator here. So we can't round this down. In order to finish the lawn, we're going to have to go back and forth 26 times. And because it's an even number, going to the right, back to the left, going to the right, back to the left, going to the right, back to the left. So that's going to take us here to, we'll call it A prime, just below A. Okay, so it's 26 rows, and each of those rows is 16.5. So let's see, we get there. So 26 times 16.5 is 429. So the distance that we've traveled you know, back and forth and back and forth is going to be 429 meters, and then we still have to get ourselves back to the beginning, so we have to add 13.5 to that. So if I say plus 13.5 is 429 plus 13.5 is 442.5, which was the answer that was given in the back of the book. So making tons and tons of assumptions there, but that would be how I would have expected they would have done that calculation. So if you were looking at this and trying to find the path of least resistance, like making huge amounts of assumptions, that would be a way of getting to the answer.